So that's why, because it is in static equilibrium, the force must go through this axial direction. See? So then we deduce that the force from this A goes through this axial direction. We can also, using the similar way, take this point A as a point of analysis. Then we know the resultant force, which is the combination of this force by this FBC and this horizontal force FA. Okay. The resultant force must also in the axial direction. Because when we take the moment about this point A, we apply the same reasoning. Okay. So in the end, we know that all the forces at the two ends of a rod must go through this axial direction. But there's a condition. Okay. There's a condition. As we deduce here, what if this rod experiences a torque, external torque? Say if has a force applies at the center of this rod. Okay. The force no longer exist at the two ends only. Now it has some forces in between. Then in this case, this axial direction, the conclusion we get does not applicable, is not applicable anymore. Okay. See the logic. This member AC, correct? If there's no external crater at in the middle or just at the beam, okay? If there's no external forces in the middle, the force from this A and F force from this C, they will definitely go in axial direction. This is the conclusion we get just now. But if there's external forces here, then it creates a torque no matter we select this FA or we select this FC. So the forces from this FC and FA, they can be in other directions. Okay. So this is a condition. Okay. So this conclusion will be very useful for later our derivation. You will know why. Okay. I will give you some examples. You will know why this member experience force from these two ends. You will have an axial loading. This will be one of the very important conclusion we get currently. So let's look at the next example. Okay, homework time. Take out your own paper, start doing some calculation, doing some practice. Okay. If you have any problems, do approach those sitting in the front. Okay, they are the teaching assistants so called. Okay, so they will be able to help you answering all kinds of questions. Okay, you can ask me directly as well. Yeah. Don't worry about anything. I'm just a student. Okay. So here, this member, okay, this is an L-shaped member with a rotatable joints at this point, B. And these two are all rotatable joints, okay. So the dimensions are all given here. If the question is, if this member L is experiencing a force P at its end vertically, what will be the force inside? Oh no, sorry. If this dB right is experiencing a force of 500 Newton, what will be the force P here? Okay. So this P actually is like something to pull down this thing. Okay. So that's why in process there's a force inside this member BD. So now if I know that this force inside this member BD is 500 Newton, what will be the force here? What will be the force I apply here? Yeah, so take out your paper and start. Do some calculation. thought that's the answer. I just said in the start and in the very beginning, in this lesson, you are supposed to ask any question that you want to ask. Okay, don't hide anything. Here are all fellows. There's no professors to tease at you, to laugh at your mistakes. Okay. For those sit in the back, maybe you want to come here also, because later I want to use the whiteboard. But anyway, just make yourself comfortable.